All right, folks. Um, we are going to spend a second day today on order of operations. And the reason for this second day is that we are going to be looking at some problems that are a little more complicated than the ones that we did on the first day. So today, you will continue to evaluate numerical expressions using the order of operations. Now, let's not forget from our discussion yesterday that evaluate means we're going to find the value of, we're going to work it out, we're going to figure out what the answer is. A numerical expression has no equal sign, but it does have numbers and operations. And then to evaluate these, we're going to be using our order of operations. We are changing, remember, from PEMDAS to GEMDAS. Okay, grouping symbols we're going to do first. Exponents we're going to do second. Multiplying and dividing we're going to do from left to right. And then we're going to finish off by doing addition and subtraction again from left to right. Okay, so a few examples today. All right, here's our first one. Take a look at this problem that we're going to evaluate. I'm going to come over here again, just like I did yesterday, and I'm going to write down GEMDAS so I can use that to kind of guide my work. Now, here's where things today are going to be a little different than they were yesterday. Okay, so let me kind of point this out to you. We're going to start by looking at this problem to see if there are grouping symbols, and there are. I notice right here that there's a set of parentheses, and there's stuff to do inside of those parentheses. Now, the thing is this time, the thing that makes this problem different is that you'll notice that inside these parentheses, there's more than one thing to do. There's subtraction, there's an exponent, and there is a multiplication. So I have all of that going on inside of my parentheses. So instead of just having a simple little problem inside my grouping symbols, I have a multi-step problem inside my grouping symbols. So what I'm going to have to do is I'm going to have to take this problem, this multi-step problem, and I'm going to have to use GEMDAS to evaluate this. All right, so take a look at what you see inside of the parentheses. Okay, so we're looking at just this part of the problem. Are there any grouping symbols inside the parentheses? And the answer is no. So this is already done. Okay, but then I'm going to look at this. I'm going to look at what's inside my parentheses, and I'm going to see, are there any exponents there? And the answer is yes, there is an exponent inside of here. So I'm going to do this 2 to the second power right now. Okay, so parentheses, 42 minus 2 to the second power I know is 4. Remember, that's 2 times 2 times 5. Close the parentheses, and then I have minus 7 times 2. Now I want to point out here, we're still not done with these grouping symbols because there's still more stuff to do inside of there. So when I look, and again, keep in mind, I'm just looking at this part of the problem, I have done the exponent that was in there, so that is done. All right, now, looking at just the part inside the parentheses, does it have multiplying or dividing? Get my highlighter out here. So does that problem inside those parentheses have multiplying or dividing? And the answer is yes. So the next thing I'm going to do is this 4 times 5. So again, parentheses, 42 minus 4 times 5 is 20. Close your parentheses. Then you have minus 7 times 2. All right, now notice my grouping symbols are definitely getting simpler, but there's still one more thing to do in there. So I'm going to do adding or subtracting. And inside these grouping symbols, I have subtracting. 42 minus 20 is 22. and then I've got minus 7 times 2. So let me stop there just a minute, make sure we understand what just happened. When I looked at this problem, it had grouping symbols. Inside these parentheses, I had a multi-step problem. So I have to use GEMDOS on this multi-step problem. So I have to keep working on that until it's done. So this just kind of hangs out over here and waits on me. I had to do my exponent, got my 4, then I had to multiply, got 20. 42 minus 20 gave me 22. I finally, at that point, had finished everything inside the grouping symbols. I hope that makes sense. If it doesn't, you'll be sure and let me know. Okay? Now, look at where we are right now. Continuing on, the next thing I'm doing is I'm looking at this part of the problem to see if there are any exponents. And when I look at this, I don't see any exponents. So that part is done. All right. So now I'm looking at my problem for multiplying or dividing. And I see multiplying right here. So the next thing I'm going to do is the 7 times 2. So 22 minus 7 times 2 is 14. In my problem now, I don't see any more multiplying or dividing, so I can check that off. And now I'm down to the end, to the adding or subtracting. And all I've got left to do is this subtraction. So now I'll do 22 minus 14, and the answer should be 8. So the value of this expression is 8. So again, starting with my grouping symbols, I had these parentheses. Inside, there was a multi-step problem. So what I have to do is, again, use the order of operations to work out that multi-step problem inside those grouping symbols. I have to keep working on just that until I get it done, and then I can continue on. All right, so there's example 1. All right, here's another one, example 2. So take a look at this expression we're going to evaluate. I'm going to come over here. And write down GEMDOS. Get myself ready. All right. So the first thing that I'm going to look for in my problem is grouping symbols. This problem has grouping symbols. 2 to the third power plus 4. So notice I have an exponent and I have an addition in there. So that is a multi-step problem inside of those parentheses. So now what I got to do is do GEMDOS on this. Okay, so does 2 to the third power plus 4 have grouping symbols? No. So that's done. Does 2 to the third power plus 4 have an exponent in it? The answer is yes. It has 2 to the third power, so I've got to do that. All right, so here we go. Starting from the beginning of the problem, I've got 24 divided by parentheses 2 to the third power means 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So I'm replacing 2 to the third power with 8. Plus 4 minus 9. So now I'm taking care of that exponent. Now, still working inside these grouping symbols right here. Still working inside these parentheses. Do I see multiplying or dividing in 8 plus 4? And the answer is no. There is no multiplying or dividing in there. Do I see adding or subtracting in 8 plus 4? And the answer is yes. So the next thing I'm going to do is 8 plus 4. So 24 divided by 8 plus 4 is 12 minus 9. And notice at that point when I do the 8 plus 4, I have completed everything that was inside these grouping symbols that we were working on. So the adding and subtracting is done. I have finished this part of the problem, that 2 to the third plus 4. So here's the point I'm trying to make. When you look at your grouping symbols and inside you see a multi-step problem, then you have to use GEMDAS on that multi-step problem until it gets down to the point where it's one number. Okay, so now I have finished these grouping symbols that I saw in my original problem, so I can check that off the list and continue on. All right, so now in this problem that we have in front of us, do we have an exponent? And the answer is no, that doesn't have an exponent, so we can check that off the list. All right, in my problem that I have in front of me now, do I have multiplying or dividing? I see dividing, I see subtraction, so yes, I have dividing. So the next step for me will be to do 24 divided by 12. 24 divided by 12 is 2. So I have 2 minus 9, and now I am finished with the multiplying or dividing. The only thing left in this problem is a subtraction. Add or subtract. So I am going to do 2 minus 9. 2 minus 9 on this problem, and that's going to give me a negative 7. So the value of this expression that we started with is negative 7. So notice again, when you started out with your grouping symbols, you had an exponent and addition. We have to follow the order of operations to work out just that little multi-step problem right there until I get to the point where it's one number. And then I can come back over here and complete these steps. Now again, if that's not making sense to you, you email me, you let me know. All right, now, here comes probably everybody's favorite. I know how much you all love fractions, right? Okay. Yesterday, when you watched your video, one of the things that we talked about is that this fraction bar right here in your problem is a grouping symbol. Now, how is that fraction bar a grouping symbol? Well, it's a grouping symbol because it creates two groups. You have your top, that's one group, and then you have your bottom. That's another group. So when you have a problem like this one, when you have a problem where there's a fraction bar, here's how we're going to have to do this to begin with. Okay? We're going to have to treat the top like it's one problem and the bottom like it's another. So I'm going to copy the top problem over here. It's 10 plus 5 to the second power times 2. And then I'm going to copy my bottom problem over here. 12 minus 2 times 4. And what I'm going to have to do is use GEMDAS to work out this problem. And I'm going to have to use GEMDAS to work out this problem. All right, so let's start with this one. Let's start at the top. When I look at my top problem, does it have grouping symbols? And the answer is no. So that part, done. Can check that off the list. When I look at my top problem, does it have exponents? And the answer is yes. So I am going to do 5 to the second power first. So starting from the beginning, I have 10 plus 5 to the second power, which means 5 times 5. That'll become 25 times 2. Now looking at that, any more exponents? The answer is no. So exponents are done. Now I am looking for multiplication and division. So when I look at my problem, I see a multiplication right here. It's the only one. So I am going to do 25 times 2. So starting from the beginning, I have 10 plus 25 times 2, which is 50. When I look at my problem now, no more multiplying or dividing, so I check that off. And so now I'm at that very last step. Do I see adding or subtracting in my problem? And the answer is yes, I see an addition. So I'm going to do 10 plus 50. 10 plus 50 is 60. Now, that's not the answer to this question. That is just the answer for the top. So I'm going to go ahead and come over here and put my fraction bar back. And on top of that fraction bar, I'm going to put 60 because 60 is the value of just the top. All right, now moving on to my bottom problem. I'm going to go through my same process. When I look at this bottom problem, do I see any grouping symbols? The answer is no. So grouping symbols are done. Now looking at my bottom problem, do I see any exponents? The answer is no. So exponents are done. Looking at my bottom problem, do I see multiplying or dividing? And the answer is yes, I see 2 times 4. I see a multiplication, so that's what I'm going to do. So working left to right, I have 12 minus 2 times 4 is 8. 12 minus 8. No more multiplying or dividing in that, so I'm going to check that off. And now again, I'm down to that last step. 12 minus 8, adding or subtracting. And 12 minus 8 is 4. So the answer for just the bottom is 4. So I'm going to come back up here. I put 60 as the value of the top. I'm going to put 4 as the value of the bottom. Now, what I have to do to finish this problem off is work this out. You all know that a fraction bar means divide. So this actually says I want to do 60 divided by 4. 60 divided by 4 is 15. So the value of this expression is 15. So a fraction bar is a grouping symbol. It creates a top group and a bottom group. And what you've got to do is work that out like it's 2 separate problems. Work out the top, figure out what its value is. Work out the bottom, figure out what its value is by using GEMDAS. And then at the end, you can put those 2 values back together and divide to get your final answer. So 15 is the value for this example. Okay, now I thought to finish this off, we would do one last fraction just to be sure that we had it. So again here, my fraction bar is making those 2 groups. I'm going to draw my line here to make myself a place for the top and for the bottom. My top problem is 8 minus 5 times 7. And the bottom is 19 minus 5 minus 1 squared. I need to evaluate both of these problems. So, GEMDAS for both. All right, so I'm going to start out on the top looking for grouping symbols. This problem, no grouping symbols. Now I'm going to check my problem for exponents. No exponents. Now I'm going to check my problem for multiplying or dividing. See a multiplication right there. So I am going to do 5 times 7. Working left to right, I have 8 minus 5 times 7, which is 35. Okay, no more multiplying or dividing in that problem. It's just 8 minus 35. So my last step will be to add or subtract. And in this case, there's only one of those to do. 8 minus 35 is a negative 27. So negative 27 is the value, but just for the top. So again, come up here, put your fraction bar, and on the top, put that answer that you just got, negative 27. I should say here, I'm doing a lot of this math mentally. If you're not comfortable doing that, if you need to use your calculator, please feel free to do that. We certainly would if we were in class together. So you know, no worries there. You are more than welcome to use a calculator to help you with these steps. All right, so now I'm off to my bottom problem. I'm looking for grouping symbols in this bottom problem, and I see them. right here, parentheses. And I want you to notice inside there's only one operation to do. 5 minus 1 is it, so we're going to go ahead and do that. It's not like those first two examples I did today where there's 2 or 3 operations in there to do. There's only one to do, so we're going to do it. So this is going to be 19 minus 5 minus 1 is 4 squared. Now, grouping symbols, we still have our parentheses, but only one number inside. There's nothing really to do in there, so we can mark those grouping symbols done. The only way you have to worry about grouping symbols is that there is something inside of them that you can do. All right, so now I'm checking this problem for exponents, and I see them. So my next step will be to do 4 to the second power. 4 to the second power means 4 times 4. So this is going to be 19 minus 16. No more exponents in that, so those are done. All right, now I'm looking for multiplying or dividing. 19 minus 16, I don't have any multiplying or dividing, so that's done. And now we're down to the end. I'm looking for adding or subtracting in my problem, and I have 19 minus 16, which I will do. 19 minus 16 is 3. Now keep in mind again, that is not the answer to the problem. That's the answer to just the bottom. So I'm going to put 3 right here. So I got negative 27 for the top. I got 3 for the bottom. To finish this off, negative 27 divided by 3 gives me negative 9. So negative 9 is my final answer. Negative 9 is the answer for the entire expression. So to kind of recap what we're doing today, still GEMDAS, but 2 new kinds of problems. When you see a fraction bar, remember it divides your problem into 2 groups, top and bottom. So use GEMDAS to do the top, use GEMDAS to do the bottom, and then put those 2 numbers back together and get your final answer. So that's how we handle those. And then the other thing we talked about today is problems like this, where when we look at our grouping symbols, we have more than one operation to do. So like in this case, it's an exponent and an addition. So what we have to do is use GEMDAS on that little part of the problem right there, on that multi-step problem, and get that down to one number, and then we can continue to evaluate that expression. If you have questions, if anything about today's lesson didn't make sense to you, then contact me. Let me know. I'm here for you. Assignments posted. Give it a try, and we'll see how things go. Y'all have a good day.